Alright, and then apparently once we have this, we can write the following. Monad. So, isn't this just... It is. We could make this point free, but I'm not going to. Okay, so it says, convince yourself. This is an exercise, by the way. I don't know how this is an exercise if they don't. 13, 20. Alright, so we'll try to convince ourselves that this works. First, we need to like relook at the, or just look at this again. If I recall correctly, we basically have created a state monad. So I don't remember exactly what this optimize function was doing. I think we wrote it. Let me bring it up. Where would it have been? On the previous page. So I don't know. Maybe here? Might be this one. Yeah, okay, so what's up, Swarm? How are you? So we're trying to understand again what this optimize function does. So it's trying to eliminate cases where we know it's trying to optimize away like calculations. Or recurse through. I don't remember exactly what this is trying to do. Okay, so it says okay, so this one basically does nothing, I think. This is like the well, no, it's continuing through the chain of commands. What's up, Bloomy? What is this pop doing? Seems to me like these are doing nothing in some sense. Like they're just continuing the recursion through pop and push. So basically what we're doing here is if we have a push followed by a pop, that's exactly the same as this, I guess. If you pop right after a push, there's no need to actually perform the operation. Because basically you're putting a value on and pulling a value off of the I stack. So let me just double check these types real quick. It takes an integer. This is going to be an integer. Okay, that makes sense. So here, what's the type of P? It says performing the optimization now amounts to interpreting the monad in an initial context. In this case, we choose return since it does not affect our optimization. In other cases, we might need a special starting value. Convince yourself that this code works. Here we are using the monadic computation P with the type, which I had up here just a second ago. That's the type of P. Since the result is yet another computation that is parametric over monad I stack coupled with the final state, we can just throw away the second part. What? I mean, I see how this is a natural transformation. How is this optimized, though? Is this a different optimize? Or what am I missing about this? Did we already implement the optimization? Is that this? Yes. Okay. So they gave us this code basically. So we're saying if the last thing that was given to us was a last push n, we can just return that as a return type. Only for pop. Okay, I get it now. So if it's a last push followed by a pop, we're basically doing the quote-unquote optimization inside of this pop. What is this thing called? It's not a data constructor. What are these things? What's the terminology here? I mean, I know that that's a GADT. GADT Haskell. Sure. This should be good enough. Class. A type class. Wait, is that not a GADT? That's not a GADT. That's just a type class. I'm stupid. So this is just a member of said type class, I guess. Is that the term they use? I said GADT. That's not a GADT. GADT would start with data. Member function. Okay, that's the term. Member function. Easy. So we basically implement the member function to include our optimization, and therefore, again, the only reason we're using this last operation is to get an idea, deal with this optimization thing. So once we're done with once we implement this, we can just throw it away. So that's what this is doing. Okay, I understand what's going on now. Sorry, this is a little confusing. All right, so so this is going to be type class method. I mean, it says here member functions. Oh, well, maybe that's not. Oh, I'm looking at right. Hang on. I probably could just have searched Haskell org, but associated operation, just operation maybe. Class method. Got it. Thank you. So we're gonna move this to source inspecting. I don't know. Okay, so this is free applicative. Okay, so blah blah blah. We've talked about this before. We're gonna define this time. We're gonna define an actual GADT for a free applicative. So it's usually very unhappy when I do what I just did. And by it, I mean the language server. So I may need to restart. I assume this is what this is going to look like. And we will restart the language server and see if that makes things happier. Okay, so it says if you flip the arguments, it looks almost like the apply operator we're used to, but you'll see like these two pieces are flipped, right? We have FA and then FAB, kind of the same, not exactly the same, obviously. The difference is that, right, we're recursing. We have to build a new app, which we're kind of familiar with at this point. The applicative instance highlights this fact by swapping arguments in the apply. Okay, so we're gonna write instance functor f where and functor. So this is like mirroring free. Well, it's free applicative, that's why. It requires a functor still. Oh, and does it? Yeah, it does. Okay, good. Okay, so does this make sense? We're f mapping f compose onto y. So f is a to b. Oh, right. We're gonna have tricks here because of this thing. We should put, if we really want to see these types, we need to put holes here. So we can put a hole here. And you can see that this is a an A to B hole. We could also probably write the following. To see that this is A to some other value. So this needs to produce a B, so that's F. And then we can look at this. Yeah, it still looks kind of funny. But that's okay. I was hoping it would be nicer. Oh, I guess it does say A to A1 there. So that's fine, I guess. And let's just do that. Okay. Instance. Map Y. Map X, Y. Z. Map X. Lip. It's interesting. That's pretty interesting. So we need something that looks like an A1 to A to B. What's the type of Z? Oh, right, that's just an app. So this is the recursive call here. Interesting. It's pretty weird. An interesting fact about free applicatives is that this definition apparently isn't the only obvious one, or the only possible one. There's a Flavors of Free Applicative Functors from 2013. There's apparently 4 different versions of this. It's kind of cool. So you can write, for example, kind of like inverting. I don't know what the right term is here, but like trying to flip the recursion around. I'm not sure if that's the right terminology, but something like this. So we'll just something like this. Surprised you didn't ask us to implement these. Usually there's an exercise like that. I don't know, we might have been able to figure it out, but it probably would have been quite tricky. Sorry, there's a big blob of text right now. There's a we can use this Koyoneta thing to apparently build a freer applicative. Okay, so then there's apparently a free operational package in Hackage that builds that. As an example of a free applicative functor, we're going to build a small library for handling command line arguments, similar to op parse applicative. That's kind of cool. So we're going to consider 2 types of arguments: command line arguments, flags, which take no arguments, and options, each given by its name followed by the value of the option. Neat. Okay. So we want a way to describe command line arguments. You'll benefit from inspecting their structure. Blah, 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 blah. Okay, cool. Oh, that's an interesting question. I don't know. They do say the difference between the instances is when and how the term is normalized to the form. And by the form, I mean basically the following. So like eventually they all end up like this. It's just how they get there is slightly different. So I think that the machine code would be different according to this. Although maybe not. I'm not entirely sure what that means. All right, so we got data arg a equals flag string bool to a. Let's put this on the other line. Option string maybe string to a. That doesn't get formatted? That's horrendous. If I do this, doesn't do anything? How strange. I also really don't like how it does this, but I don't know if that's a bug or not. Like, what I would really like it to do is like that. That would be awesome. But alas. We're gonna need probably, yep. That's not gonna derive functor automatically. You need to tell it to try. So there we go. So this just describes like whether or not it exists, and this is supposed to take on, you know, a string, and then apparently we're gonna convert it to something, and that's, I guess, its argument. So we wrap it in our free applicative, and we need to make some smart constructors. So string to command line bool flag s id period. Oh, so we're gonna take a string and we're gonna have an option string to command line maybe string. Okay. Okay, so data config. So we're gonna get, I don't know what background stands for here. I'm not sure what background means here. But we're gonna try and get the following data type, I guess. Excuse me. Okay. We're gonna have to define maybe, I suppose, somewhere. Oh wait, no, that's probably just the maybe from um data maybe from maybe. What does out mean? I guess that means like standard out in this case. Or something. Okay. So the interesting fact is that even though the definition of read command line uses fmap inside of the applicative context, the applicative instance takes care of normalizing everything to a pure function applied to a bunch of values of type arg. You can benefit from this fact to write a function that traverses a command line and returns a list of all possible flags and options. Okay, so arg names, command line A, list of string. Okay, so if we hit pure, we're done. What's up, Illusion? How's it going? I don't think I've seen you before. Are you, do you consider yourself a Haskeller? Are you into functional programming? What'd you do your PhD in? Arg app rest. Arg names. Oh, name. This is what we have to define. I see. Sorry, I was like, what haven't we defined? Arg A. String. Okay, so this flag here is just that string right there, and that's just the name, so we can just say that option name. Oh, what am I doing? Something like this. Okay, so sorry, I'm very burpy. My goodness. All right, interested in Haskell, but unsure of its uses so far. So Haskell is a general purpose programming language, so you can actually use it for anything. What am I planning on using it for? I plan on writing lots of things in it. I want to build websites, not necessarily related to like the work I'm doing at school, but I'd like to use it to build neural nets. I'd like to use it for data science. I want to use it for everything. So I think that it's the language I would like to be using for everything, but I'm currently not using it for anything production related, other than a few like libraries that I'm writing for work. Not libraries, like utilities. So like as an example, one that I have online, I don't know what field you're in, but I have like this is in very early stages, but I have a proposal system that I'm rewriting in Haskell for basically people doing computational work on the cluster that I manage at work. So I have a version of this, but already that's written in Python, but it's not very good, and it's not flexible enough. So I want to write something that's more flexible and also like for other people. So yeah. But ultimately I would like to write, you know, a computational chemistry code in Haskell. That's kind of the goal. But we're far away from that. We're kind of rolling down the rabbit hole of like learning new things with Haskell. Kind of what we're doing. All right, so what is this function doing? It takes a command line A. So if we fed this thing read command lines, it's gonna print us back background and file or something. I'm not entirely sure. That's terrible. Didn't we do this before? I thought I fixed this. change GHC prompt. Sure, let's make it a lambda. Everybody likes lambdas. So I want to close this. GHCI? Is that what it was? GHCI. Okay. Let's put like... We'll just leave a lambda in there. That's fine. Okay, that will help clean up our command line a bit, because it's a little unwieldy. What was I gonna do? Oh yeah, arg names read command line. Yeah, look at that. That's kind of cool. Okay, so it says writing such a function would be impossible if command line were a monad, but we do not really need monadic power here since we expect command line arguments not to depend on one another. Yeah, so like they also don't need to be processed in order, like in sequential order, which is why we don't need a monad, which is useful. Okay, so we introduced both free monads and free applicatives for a functor. These two structures themselves create either a monadic or applicative structure, starting with a pattern functor. However, there is another possible free construction, the free monad of an applicative. Well, that's cool. This notion is defined in the control monad free app module of the free library. That's kind of neat. Oh. Did you, you didn't answer the other question, so I'll ask again, if you're still here. What did you end up doing your PhD in, out of curiosity? This isn't even necessary. Oh, right, we need our pure type, but or maybe you're still typing. Okay, so we need free, which I think the data type is in data. No. Probably in here. Whoops, that's literally not what I wanted to do. Free. Probably need that. All right, but these pures aren't gonna work. Pure prime, pure prime, pure prime. Pure prime, pure prime. Yeah, for sure. So like one thing about Haskell is like you have to unlearn a lot of what you're already doing. Like before I did this, I did a lot of Python and C++, C, Fortran, and like most of me learning this language has been sort of unlearning the patterns and things that I think about um when I do that. So yeah, it's been kind of interesting. Isn't there a way to have duplicate instances? Options or something? Hang on, gotta look that up. Haskell duplicate instance declarations. This is just to make our just to make the compiler happy. Yeah, what languages are you familiar with? I don't see it in here. I feel like it's an overlap flag or something. I don't know. Duplicate instance declaration. Why can't I say the word declaration? There we go. Okay, fine. What do we do here? Yeah, for sure. I completely agree with that. Um, that's why I'm using Python as well, just to do basically mostly pandas, numpy, that kind of stuff. I know there's a way to do this. Can we just do this? I'm just trying to make the compiler happy. Duplicate. Is that a thing? No. Build. Okay. Overlapping instances is deprecated. Use per instance pragmas. Overlapping. I forget how I define a pragma. Whoops, that was stupid. But I think it goes here, and there's something like option. Something like this. Oh, you don't even need. Oh, nice. Why is it complaining? Can it not? Does it have to go here? Does it have to go here? After word. Oh, okay. overlaps? I don't know. I mean, I don't know what it's... I mean, okay. So what if we just get pure... Let's just remove the duplicate. So we just need pure and free. And we don't want anything else. And then that way we can just do this. I think. No, doesn't let me do that. Okay. Just copy code until it works. Yeah, it is what it is. Oh, I guess I could have just wrapped it in another free. That's a good point. But, oh well. We'll just copy this code. It's fine with me. Yeah. It's not beautiful. But anyway. Okay, so the important part is marked with an exclamation point above. So it's saying that somehow... Actually, hang on. So it explicitly defines the following, which as important, like this. So let's see if there's anything here. Because as far as I understand, that this is the default implementation for return now, and you don't need to actually write it here. In the free monad of a functor, the return operation uses the pure constructor, but here it piggybacks on the pure operation of the underlying applicative functor. Okay, interesting. I mean, I guess that's true because we're writing this for here, but this, that's not entirely obvious to me. Let's see here. But yeah, that's the, I mean, that's the pure for this free f. But isn't that just this? I guess I'm confused. Just reading. Okay, so chapter 13. This is the last paragraph, so I'm just gonna read the last paragraph, and we're gonna have a little celebration because this chapter was insane. In this chapter, we've seen how you can create your own monads using a handful of approaches: final style, initial style, free monads, and operational style, and freer monads. The next question we will tackle is how to combine several of your own. Oh my goodness. This is especially interesting when you develop a domain-specific language that may specify multiple behaviors. Spoiler alert, final style monad are easy to combine, but the others will give us more than one headache. So I guess we're going to use final style to compose custom monads. So we did it. We finished chapter 13. Wow. feel like I've accomplished something. I think this is similar to like the one chapter we did for weeks in the type class book or the type level book in Haskell. My gosh, that was hard. I think it was chapter 11 in that book. Finish chapter 13. Cool. Okay, so just for reference, if you want this code or the book, you can get it online. The code is just on GitHub, and we've done all the way up to chapter 13. We have, I think, 3 chapters left or something. So 14. And 15 are the last 2 sort of do something chapters. Then there's one called Diving into Theory. What is that one? Let's see here. Chapter. Then there's then there's 2 more chapters. So we have 4 chapters total left, basically. So as usual, we start a new chapter by making a stack project. Chapter 12, chapter 14, wrong thing. Oh well. Alright, and then I need to update the stream info. Chapter 14. Boop. Did you like the name of the stream when you popped in? Yet another chapter 13 stream. Written in kind of a weird way. Okay. So we talked about a bunch of different custom monads. Says they help you refine the language you use to develop your application in order to target your specific domain. But sometimes you need to describe a computation operating in several domains. So to compose different monads, we could use the example from chapter 11, monad transformers. This chapter introduces other ways to compose custom monads, which will eventually end up as extensible effects. And I think that was one sort of the next thing that we wanted to get into after we finish this book, or one of the things is like the libraries for the effects libraries that are out there. I think there's one from Important Shock. Haskell? Do you think that will get me there? Is it fused effects? It's one of these, I think. Yeah, Rob Ricks seems like, I don't know who owns this. I've seen this person's name attached to this, but it looks like this is Rob Ricks' project. So anyway, okay. One of these guys, anyway, for sure. And here's one. Screaming fast. F is really fast. Yeah, and then Polysemi, which is from the author of the Thinking with Types book that we did before. So yeah, we kind of want to like play around with these different libraries and see how they stack up at some point. So when we speak of composing two monads, we expect a combination to have these properties. Its algebra should combine the operations of each of its constituent monads. You should be able to describe a computation in the combined monad without any special ceremony when compared to using only one of them. Defining the interpretation for each custom monad for the same target should suffice to define the interpretation for the combination. If both monads have an interpretation in I/O, then there should be a way to get a single interpretation to I/O out of both, excuse me. Alrighty, so we're gonna start with, what's up, Pretz? How are you? Final style. So we're gonna play with final style again, which is good because I didn't fully remember how to compare it to the other situations we were doing. Alright. You'll be happy to learn that composing final style monads is easy. In fact, you need to do nothing to compose monads in final style. Wonderful. So we're going to use a monad for random number generation. Okay, so we're just going to write a random number generator, apparently. So that's kind of fun. In final style. So random gen m where random. So define type class with a member. And I assume that this is like the random state. I don't know what this one is. The last one? Oh, right. I don't know what the second one is. Our goal is to describe a computation that guarantees a random integer and then writes it to a file. We want a final result. Oh, I see. Okay, does this make sense now? So we're going to need to basically do the natural transformation at some point between these things. But basically we're writing a random number between 1 and 100 to trying to write it to a file with a certain path. That's the idea. So we got to actually write this part. So it says, in fact, the previous code compiles without any change. What? Which means that we could combine operations from both monads freely. But we can't. Okay, let's define the type. Okay. Can it find these? Replace with IO error. Okay. So Google IO error. Do I even need this? Should it match type? Yeah, I'm guessing it's changed since. Oh, right, because we're trying to use this FS monad. Hang on. So I think we're trying to get a different. Okay, I need to go get. I think I wrote this previously. Is the idea. So let's go here. FS. So we need this basically. This makes more sense now anyway. Hiding right file. Okay, so that just works, which is nice. Okay. So each custom monad that is necessary to capture all the operations appears as a constraint in the type. The trick here is that the type class and trait mechanism both already provide an integrated approach to combination. Composing interpretations is not a big deal either. Suppose you have instances of each custom monad to IO. So we'll just copy this code. Oh, okay. So I must do lib dot. This comes from control monad, control exception. Probably this one. Which one are we using? Just control exception. Okay, sure. Maybe that one's one that I can just import. Apparently. Alright, so there's the interpretation for fs, and we need an interpretation for random gen m where are we just going to use the random? So what's the point of this? Need interpretations for, that's the right way to say it. Yeah, I think that's it. You just need to make sure you have the interpretations. So, okay, that's kind of cool, I guess. But we're gonna change this to final style. Oh, and also we don't need this. We don't need this. Okay, so we're gonna have our read file, file path, either fs error unit. This is right. This is IO error. I think. Okay. Hey everybody. I just noticed there's 7 people watching. I'm super tired tonight, so I apologize for yawning and you know, stretching and these sorts of things. But I'm sleepy. Okay. So these are basically the 2 monads that we're trying to compose, and we're going to write them in like operational initial style. The book has 18 chapters and we are on 14. You must have popped in right after I said that. And we are cruising along. Although chapter 13 was really, really hard. Like, my head hurts thinking about it still. Yeah. This will be book number 3 that we complete on stream. That's the goal. Yeah. That's the goal. It's not going all that well. I mean, like, I'm an expert in the theory of how this all is supposed to work, but I've not done it in reality yet. So, like, that's the key, is to embed this in reality next. Although I still want to do other books, so I have a hard time deciding what I want to do in life. Yeah. I don't know why this is so far over. Yeah, it's a really hard thing to figure out. Like, what should I really do with my time? I don't know. I can't figure it out. There's too much to learn and there's not enough time to learn everything. So I kind of want to keep doing what I'm doing. My lips are all messed up too. So that's distracting. But we're fixing that problem. Okay. So it says if we want to put these 2 declarations together in a new fs random monad, we encounter 2 problems. We have 2 different constructors corresponding to return, right? We have fs done and rg done. Oh, this is supposed to be rg done a. Right? Yeah, that's the other thing, is like, I could watch shows on Netflix or Amazon, or I could continue watching Twitch. I mean, I'm pretty sure Strager is streaming right now. I could watch Strager. I think I was watching him earlier. He was doing OCaml. It was interesting. But, like, you know, I gotta eat. I gotta work. It's hard. Okay. So we have 2 of these dones, but we're going to have some combination of the 2 that can only have 1 return type. And there's no obvious way to remove constructors or the original data types or choose between them. The continuations, so these are the continuations. That's how we build things in initial style. And apparently operational as well, but I don't recognize them just by looking at them yet. Yeah, so I mean, I think I understand why wait, tagless final, oh, etc. I see. Yeah, tagless final is what we just did, the final style. That's the easy one. but there's a lot of interesting, these sort of combinations of monads are quite interesting to look at. Like apparently op parse applicative, which is a super common Haskell library, is built on top of free applicative, or it can be. I don't know if it actually is. Hard to say. Okay, so anyway, the continuations in fs and random gen refer back to their own monads, but this is not correct if we want operations to live in our new. So we're like talking about some fictitious fs random combination. That's what I'm talking about right now. Similar problems arise when we consider monads in operational style. Okay, so actually what we should do is move initial operational style to initial style, and then make a note here. So similar. So, okay, issues. I don't really want to write these. So similar issues apply to operational style. Sure, good enough. Okay, so back to this. Like if your project is small, you're just going to use concrete types. Yeah, concrete stacks and types. Yeah, that's probably true. And also if you're combining like core monads, they're already defined for you via the transformer stack. So it's really only when you're trying to core, what are they? I think they just call them base monads. We've heard the term before, but my brain doesn't remember. You're probably just going to use transformers because it already contains all the things you need. This is only true if you're like writing your own domain specific languages, I suppose. Or custom monads, I guess, in general. Okay. So it says the constructors corresponding to return and bind each need to be fused into a single operation in the combined monad. Unfortunately, there is no way to combine two constructors in either Haskell or Scala. Apparently, there's some research going on to make that happen in something called ornaments, if you want to look that up. I assume that will be another rabbit hole that we will avoid for now. It says combining monads written in initial or operational style is, in fact, a lost cause. So let us look instead at custom monads built using either the free or freer construction. The idea is that instead of combining the whole monad structure, we only need to combine the parts that describe the operations. They just define some arbitrary... Oh, I see. Okay, never mind. So let's put some notes in here. Section 14 points out that combining monads in initial or operational style is a lost lost cause. So we will remove it. I don't know why. I mean, I didn't read that carefully, so my apologies. So this is going to be like free Okay, so okay, so we need this basically, so we'll just stick that in there for later in case we need it in other places. And now we're gonna start working on this in freestyle, I suppose. So FSF. Well, we can just call it FS. Oh wait, right. We need to tag it with the free piece. So write file path string either IO error to R or read. Why does it do that? File path either IO error string to R. Yep. Data random gen R random int. What did I just do? Okay. So here we go. So these are, oh wait, R should be F. Oh, I could have hit dot. I gotta be better. I gotta be a better Vimmer, folks. That's another thing I need to learn how to do. More things to learn. Forever and ever. Alright, so what we want to be able to do is write the following data Okay, so here's the idea. What is this complaining about? Oh, I did it again. Keep writing data when I mean type. But something goofy is going on here. Let's just restart the controller, because like it should complain about this, which makes perfect sense. Okay. Please complain about this. Please. What's happening? Why does that compile? Question mark. What? What is this? This isn't a thing? Is it a thing? Oh. We're defining an infix constructor. This would be, I get it. What are you doing, kitty? Okay. So if I looked at its type, I need to define this. Okay. Thank you, Pretz. So this is, what am I doing here? I'm doing like a natural transformation or something between this and this or something. We'll see. Oh yeah. I've not done this a lot, as you can tell, so. Okay, so apparently we got to talk about co-products of functors before we move on. Sure. So the argument to a free or freer monad should be a type constructor, not a ground type. In Haskell terms, we say that in free, f must be of kind. Yeah, we know this. So, illusion. Thank you so much for the follow. Really appreciate that. So, this R. Well, let's do this. So free R are kind. I don't know. Sure. In Scala, don't care. Moving on. So this rules out the use of either, since those types combine ground types. Kitty, what are you doing? Hang on, I gotta check on this cat. What are you doing? Stop it. I'm gonna put this. Sorry, he's chewing on a plastic bag. He's being bad. Ugh. Where you go? Come here. Say hi. We're bad. You gotta come say hi now. Alright, so. Hi, everybody. This is Andre 3000. He's my crazy cat. Not want to stay here, so. He says hi. Is your GC the 3 GB or 6 GB version? GC. What does GC stand for? Graphics card. I don't know. I don't remember. 6. Yeah, that's why I was like, I'm not sure what GC means here. I would like to get a new graphics card, but like this one does fine for what this computer is for. Like I can play games on the Windows installation and I do my streaming from the Linux side and like it's been totally fine. So I just can't warrant spending like $600 for a new graphics card. Yeah, I think did I write? I guess I wrote this below in the description of the hardware I have, right? I don't know what I would have written. Yeah, I don't know that I would have I guess use the acronym or something. Okay. Okay, yeah, we so the point that Prutz says is like using a partially applied data constructor like either string or either int. They have the correct kind. So we could use that. Okay. And that's correct. Okay, so what we need is a data type that takes the type constructors as arguments and chooses which ones to apply to a final result type. In recent versions of Haskell's base package, you can find a version of the data type called sum, although in some places this type is called this plus operator, the colon plus thing. So do I need to define this? Maybe. Not sure. Yeah, my cat's being super bad. Okay, so we need data sum fg equals fg a in L fa in R F G A, I guess. And then we need to write, so this is an exercise. Exercise 14.1. Show that sum fg is a functor if both f and g are functors. Could you stop? Seriously? Jeez. Instance functor f functor g functor sum fg where f map f in L Okay, so one thing I haven't talked about at all on the stream is this concept of holes. And for illusion, I think this might be pretty cool, or you might think this is cool. So basically, holes give you a way to basically determine the types of things that you're unsure of. So like you can just put in holes all over the place, and it will, if you hover over them, or really what you're, I have this entire stack running, but if you run, it's a language server and things, but if you write this, you'll see, you try and build the code, you'll see found hole, B, so it kind of tells you the type. Now, this isn't particularly useful in this case, but essentially you can see that like we need a sum FGB. So we can use something that people like to call like hole driven development to do this. So essentially this becomes, I mean, I know the answer. So it's just fmap like so, I think. Yeah. Yeah, so you can also have, so like if we did I, that's 13 though, so we need to get out of there. So if we do stack REPL, you'll get the same error and you can look at it. And then if you do :R, which is the short for reload, you can see like, again, here's your hole. Another option is there's yet another tool that you can basically open in like another terminal called ghcid. And it basically will, every time you save the file, it will rerun this thing and you can look at the holes. So like if we did in R A, we save that and now we can see A has a type GB, and you can just keep working through this. There's actually another programming language called Idris, which like you can expand the code based on the holes and it will like fill in the holes for you. So it looks pretty cool. I haven't used it yet. Jappy on Twitch also has done it, has used a little Idris, but I think he's doing Agda now. I'm not sure why he moved on. Yeah, it's very useful when you get stuck. Like sometimes you get stuck and you're just like, what do I do here? It's like, I don't know. And having the holes can help you. So sometimes like you can try like different things. Like for example, this will not compile. So you see the red arrow over here, and you can know that this code will not work. Like you're definitely not using applicative here. You're going to use fmap, and the fact that this returns a warning means the code would compile. So that's kind of a really useful feature. You can like almost prototype like shapes and see if that works. He didn't play with the interactive Idris holes part. Oh, that's unfortunate. That seems like one of the coolest selling points, is that it can determine, you know, what the holes are supposed to be. Okay. Anyway, that's kind of cool. So I think that this is essentially what we got here. Can I abstract further and just make this a C? I don't think I'm allowed to. Yeah, I think I have to explicitly write that there. I don't think that that's that surprising, but anyway. RLG. I mean, isn't that going to be true for Agda as well? Although maybe he's not doing Agda either. I haven't been able to watch anyone stream recently. Okay. The coproduct of functors provides the combination operation that we are looking for. The same construction works for free and freer monads, since in both cases we need to combine type constructors. Now if we were to define a computation that uses fs and random gen operations, we can assign it the type So I guess we would write something like, seriously, dude, this cat's really annoying right now. Okay. He just wants love. Will this compile? Okay, so Idris does not have integer division and GCD theorems in standlib. Okay, interesting. Yeah, I think that's generally true from what I've read about Idris as well, so. Is this what this means? It says we can assign it the type free FSF. That funny. Maybe it's supposed to be FS random. Oh, that could be. But is this type just FS random? Random gen F. I'm very confused about this. So I think that this is not. Maybe what I'm supposed to do is the following. Okay. And then we should be able to your so I might think it's something. So in our maybe you confused me. I think I'm just confused at the moment. Because this paragraph is not very clear. But maybe I should not do what I'm doing and keep reading. Because I see some code in here that looks like it's what we need. So let's keep reading and not get ahead of ourselves. Because sometimes we get ahead of ourselves and we just solve what's already in the book. And also sometimes we get stuck when we do this, and it's because we don't read the book. So, you know, you never know which path we're gonna end down when we do that. Unfortunately. Okay. So I think we'll see how to use this in a second. So it says the next question is how to combine interpretations for several pattern functors into a single one. We are interested in interpretations that can describe as a natural transformations. So we need to define interpret equals fold free, excuse me, interpret prime, where interpret prime can't type. We've lost the ability to type, folks. The heck is this M? Oh, right. That has to be some. We're doing this has to be a natural transformation. So we need to fix M. So that's the key. Hey, what's up, Warren? Did you change your color to green? Were you yellow before? You're throwing me off. Trying to confuse me. I see how it is. So first of all, this needs to go away. But let's like make some syntax that's not Haskell-y. I think you can choose the color. If you go into your chat settings, I want to say. Oh, well, these are different. I'm in the oh, I can switch to non-mod settings. Yeah, so in your identity, you can just change your color if you want. I feel like you were yellow, though. Well, random color it is. You're going to throw me off every time. Not really. I don't know why it threw me off this time, I suppose. Anyway. So, interpretations will take the following shape, where M is the monad to transform to. Something like that. As a consequence, when we use free or freer monads, the question of how to combine interpretations becomes the question of how to combine interpretations from F and G into a common M. Such a function just needs to redirect each request to the corresponding monad. So combine FA to MA. So that's our interpret, one of our interpret functions. our other interpret function interesting. Underscore G in R X equals G of X. Okay, so basically, we are working on chapter 14. So we're talking about combining custom monads in Haskell. So we first looked at how to combine custom monads in final style, which is like a cakewalk. It just kind of works. And now we're talking about how you combine monads in free or freer style. And we also found out that in initial and operational style, it's basically impossible to combine monads, custom monads. So that's what we've learned so far. And we're done with chapter 13, which is awesome because it took us forever to do that chapter. And I'm tired of saying that I'm doing chapter 13. All right, so this is kind of interesting. It's like, give me the interpretation in for the left, the F. That's okay. You start streaming, and you'll finish it relatively quickly anyway. If you keep a consistent schedule anyway. That's why I do it. So yeah, anyway, give the interpretation for F, give the interpretation for G, and I'll show you how to, and I'll give you back the interpretation that you need based on in L or in R, I guess. Neat. Neat. Okay, so thanks to coproducts, we can start to describe at least a type you use to combine several custom monads. Their readability is not good. Operations do not come from either FSF or random gen, but from a different type. This type, basically, for the one we made. This type, rather, FS random. To this one? Yeah, more or less. Yep. Kind of the same idea. You're just missing the embedding, right? Because the A's and B's are embedded. Oh, yeah, so you're saying. Yeah, it's going to be essentially the same function, right? The only difference is the kinds. That's the only thing that changes. Right, this just can't be an A. Yep, yeah. We've used that function before. That's a useful function, actually. I don't remember why we needed it last time, but we needed it for something, and it basically saved the day. I think it was in that Slurm bank thing that we were working on, or Slurm proposal system. Okay, so smart constructor. I think this is right. All right, so we need to go get lift F, but is this just provided to us? Well, we don't want to use that implementation, I don't think. But maybe we just can? Yeah, I don't want to do that. We want to go grab this. I think these are different types. FSF. Yeah, this is different. Where do I use this? I just use it here. So what I really want is, I think I want this type declaration. Let's leave that out of here. It doesn't matter. So this is going to be free FSF gen random gen f. Like that. Okay, anyway, so I'm loving Firefox's new picture in picture function. I don't know what that means. Could you explain what that means? I haven't used Firefox in a long time. Okay, so for every ADT abstract data type, for anyone that's not hip with the lingo, you can make a function which can be used instead of pattern matching on it. Make a function which can be used. Interesting. Maybe for maybe, either for either. Okay. Yeah, I guess that makes sense. Okay, so let's... No instance functor FSF. Right. This requires that these things have a functor instance. Wait, that are... What needs a functor? Yeah, the base monad needs a functor. So I need to define instance functor FSF. Where? Okay. So I'm going to read this comment and then I need to use the bathroom. So Firefox is able to capture only the video screen and have it display anywhere on screen, rather than popping the whole web page in the corner. Oh yeah, I guess I could just try and derive functor. That's a good point. I usually write the instances, but I think we're at the point where I should probably just start deriving them. Capture only the video screen. I don't understand what that means. I'm gonna have to try what you're talking about. Let's see if we can just straight up derive functor from this deriving. Yep. The nice thing is our little tool tells us. Okay, so that should make everything compile, and then we need to write our file path fs random either IO error unit string. Yeah, so these are like in the terminology that they're using in the book, they're called smart constructors. You're basically just taking your base types and lifting them into the context of the combined monad. So, and you're doing it at two levels, right? We're doing it at the level of our data type here, and we're doing it, our data type here, and then we're also doing it with our combination data type, or our sum data type path. So that's that one. I'm guessing there needs to be an id at the end of this. What did I do wrong? Free FSF random gen f either IO error string read file path lift f. Oh, duh. Wait. Right. In out. I had in R here. The in R is only going to work for random. So random is going to take two integers and produce an fs random int, I think. Yep. And we're gonna say like xy equals lift f in R random gen, no, just random xy id, I think. No, this one doesn't have the recursive piece at the end, so it's just this. Okay, so these are the smart constructors, and then I think we'll keep going, I guess. for a little while and talk about this section is called automatic injection, by the way. So they're saying that this is far from ideal because we've literally redefined our, if we were to write this FSF and random gen F, we would actually already have smart constructors that exist, and we have to redefine them essentially. So yeah, I see how what they're saying is this is not useful. If we want to use FS with a new network monad, the previous definitions of write file and read file are no longer valid since they refer specifically to random gen. Yeah. The ideal solution is to make smart constructors generic with regard to the actual combination of functors used as arguments to free, provided that FSF is one of its components. We usually refer to this problem as automatic injection. We want the operation to inject itself into the corresponding part of the sum type. Interesting. Okay. When encoded in Haskell, so this automatic injection thing was described in a paper, Data Types a la carte. I think you would say this Svierdstra 2008 maybe? I'm not entirely sure. I don't know what kind of name that is. It's probably something like Vierdstra or Svierdstra, if I'm pronouncing it anywhere near correct. Anyway, so we have to define this class G where inject but that doesn't look like a injection to me. That looks like a natural transformation or something. Ew. You prefer arrows and the walrus for equal? Or do you mean equal for I guess we're comparing this to mathematical notation, right? I'm not sure. But I find R really hard to read because of that left arrow. And I don't particularly like the walrus operator in a lot of languages, but just one extra thing to parse. Yeah, so illusion as an example, like we often go read the source code for libraries to figure out how they work. Yeah, I would say my Python programming has improved a lot from doing Haskell, except that the only thing that's kind of annoying is that Python pisses me off way more often now because of Haskell. So like, I really wish that Python had native typed collections. I think that if it just had typed collections, I would be a lot better off. But like, I try not to modify state, and if I do modify state, I do it by returning new objects. So, but yes, I think it has. But one problem is that by writing Python often, sometimes I don't think like you would think when you're writing Haskell. So you write things very like imperatively, like do this, then do this, then do this. And in Haskell, you don't really think that way. It's like, I have this data type, how do I convert it to like A to B? Well, I use fmap or something. And you think differently when you're writing Haskell versus Python. Yeah. The simplest. Okay, so anyway, instance. Does this actually compile? That's kind of fun. Oh, this specifically fails. That's kind of cool. Well, maybe it does. I just need to turn on some things. Okay, so thing is, most people think that procedural stuff is actually weirdly more intuitive, and mathematical reasoning isn't. Ignorance is bliss. I was programming 10 years in C# in the most imperative way possible, and I was, yeah. Apparently there's a JavaScript version of SICP out there. They like redid it for JavaScript. Illusion, absolutely not. But learning category theory, I think the idea, so we're trying to learn category on the theory on the stream as well. So it's going a little slow, so we're actually changing it. But we do another book. We do like a book club Mondays, the third Monday of the month, trying to learn category theory. But what I get from category theory is it shows you how to construct programs or ideas from a much higher level. So like, instead of thinking about actual implementations of things, you think about how things should fit together instead of like specifics. And then once you have this idea of like this higher level, or I guess this is how category theory helps programmers, by thinking about this sort of higher abstract way of things connecting together, it can help you write better code, because you're thinking of things at a larger scale, or more generically. Maybe I'm not entirely sure. I haven't gotten far enough to get there, but it's not required just to write Haskell. The category stuff is not beginner friendly at all. Yeah, but is this beginner friendly? I mean, if Illusion asks a question, we will absolutely answer it. But is this beginner friendly? I don't think so. I've never claimed to be beginner friendly on this stream. I want to dive all the way down into the depths, the gutters of Haskell, and learn it. Oh my goodness. Okay. Anyway. Well, okay, that's true. I mean, I guess you're right, but like, this doesn't mean anything to anyone. I don't think. I mean, it means something to me. It means something to you. Yeah, but you're right. I mean, it's just function application. So this function does something. These functions do something. Well, they're data constructors, but anyway. This is weird. I've not written code like this, and it's strange looking. Like, I'm used to writing these as names, so these operators are throwing me off for whatever reason. We don't write a lot of code like this. This is really weird. Like, is this beginner friendly? In our oh yeah, I think we need this. Okay. Yeah, we can put them in the front if it throws me off enough, but it's okay. I need to get used to it, that's all. It looks different. Looks different than I'm used to. Okay, so why does this one work? Yeah, I don't know. I mean, I think beginner friendly is also relative, right? Like, if you show people examples of why they need these things, then it's probably a lot easier. But gosh, this is not a very simple compose function, though. Yeah, I don't know. Like, even looking at that, right? That's function application, or well, function composition, and that's pretty tough to read. So this means yeah, it's tough. I don't know. Apparently, there's another paper composing and decomposing data types by Bahr in 2014, and there's a comp data package to make this uh, to write these. So with this, we can basically change our write file and read file. I'm just gonna put an underscore under there. So functor fsf colon f. Do I actually need these parentheses? Oh, hang on. Um, there's a lot of stuff you wouldn't encounter in other languages, and the learning curve is pretty much exaggerated. Yeah, I mean, Prots, anything like if I was doing this every single day for, 7 hours a day, let's say, I would pick this up so fast. Like it would become, everything would become natural and it wouldn't bother me at all. But I still don't believe that this concept of automatic injection is like simple. This is not simple at all. Like whether or not this code is hard or not hard to read, right? This concept of doing this is not a simple thing. I mean, it's an academic paper. Someone very smart figured this out. And now we get to use it as a tool. But that doesn't mean it's easy. And like we've been working on Haskell for sure 6 hours a week, but for a year, I think we've had affiliate for almost a year. So, and some of this stuff just doesn't feel natural to me. So, I don't know. And I shouldn't need that, right? That's actually a parse error. Okay. It's interesting. If I use the... Yeah. I'm not saying you're wrong. I'm just saying that, like, being able to figure out what this is, like, okay, I'm using a composition between these functions. Yeah, that's easy, but like the entirety of this whole process is non-intuitive for a beginner. Like what? Yeah. But I think that if I did this like more of a job, yeah, exactly. This is used in large projects with, many moving parts that are probably worked on separately and these sorts of things. And actually, to be fair, this style is probably never used, right? They're using mostly the final style because it all of these monads just compose. Anyway, okay. Yeah, so then we have these, and then we can also have our random, which is functor f random gen f int to int. Yeah, no, I mean, the explanation of these individual components, inject, dot, in are not complicated at all. They're just types. You're just playing, you're just assembling puzzles. I suppose that's true, but I'm not a software engineer. At least I don't think of myself as a software engineer. I should probably be a software engineer at some point. That would probably be a good job to like build puzzles. Okay, and then we can finally write this. Well, that's true. Another issue. Even if I wanted to, I wouldn't be able to learn this language. Or likely, right? Nope. IO error. Yeah, but how? I really don't like when they show me this kind of stuff. Like, just give me the code snippet that is required to fill this in, or make it a actual function. So I presume that we're in the free monad. So if we need a number, we can do lift f random gen I'm not even sure if this is right. Just guessing. No, this is not right. It should be random it's simple, so fine. I thought it was going to be harder than this, so I apologize for getting mad for no reason. We just use our constructors like before, so the only thing that's changed is the way our constraints are built. Ow. Yeah, that's true. Like, you're going to learn about kinds a long time before you touch this stuff. One thing that's really interesting about this is I've not ever defined how to do these things, right? We've literally only defined the types. We haven't defined how you do anything. You still need to write the interpretations for all of this stuff. So that's kind of interesting. Okay. Scala section. Skip it, folks. Goodbye. Sorry, I don't read or write Scala at all. So it looks like foreign gobbledygook to me most of the time, especially when we're doing this higher level code, essentially. That being said, I almost want to learn Scala because if I wanted to get a software engineering job where I could do like actual functional programming, Scala is a pretty popular language to do that in. Although apparently I've heard stories that most places that say they're doing functional programming in Scala aren't. So kind of problematic, I suppose. Well, SQL is functional, right? It's basically a functional domain specific language. or declarative. Declarative is probably a better term. I keep saying functional, but I mean declarative. Yeah. I actually did try to learn Scala a while ago, but I was trying to write little scripts for people at work, but the Java boot time took too long, so nobody wanted to use them. They're like, this is really slow. Like, well, it's not really slow, it's just that you gotta wait. It just didn't work for me. Most of the stuff I'm doing is very small. Alright, anyway, enough about Scala. So we're going to talk about extensible effects. So this is section Lumi's going to sell us Clojure. No, I'm just kidding. Know of people not doing FP in Clojure. How many would you say comparatively? How many jobs, if you were to look up jobs, how often do you see professional Clojure versus like professional Scala? With FP mentioned, I suppose. Because I mean, for somebody choosing a language, that would be pretty important. For me, I don't care. That's a different story, right? Okay. So these are extensible effects. You just gotta wait. Yeah. Yeah, okay, that's true. Can't talk about FP versus non-FP. Is there such thing as non-FP Clojure? I mean, by definition, it's a pretty declarative language, right? Again, we're using functional programming very loosely, just for reference. Okay. So that's interesting. That's interesting. Something to think about. Something to think about. Okay. What time is it? It's 10:15. Are we gonna get anything done before? Let's see here. Oh my goodness. Is there an exercise anywhere? Well, this is actually a really short chapter. Maybe we'll just finish this. Although it's probably going to be a little intense. Okay, so extensible effects frameworks use a single monad, usually called EFF, that is parameterized by a list of allowed effects. Those effects corresponds to sets of operations. Computations may request operations by sending messages, which are ultimately turned by handlers into actual work. It almost feels like, almost sounds like an actor or something. Anyway. Yeah, I don't have a distract. I should have one. We can make one real quick, I suppose. I need or a stream wins or something like that. Oh, we're gonna need some union. We're gonna need some type level business here. Aren't we glad we did some type level programming? Although I guess there's actually no type level programming here. Okay, kind signatures. You got it. What next? Stop it. I did mean to use data kinds, but just do it. Okay. Type operators. Yeah, I guess you're right. What next? GAD teased. Yes. We're almost done. We did it. I don't know why it was being so slow. Okay. The EFF library, oh, that's Scala, don't care. The next step in building our extensible effects monad is to define the notion of a member of a type level list. It is a type level list, yeah. This is a predicate over types that says that a certain type constructor F is part of a list. This definition can be turned into a type class with instances that implement linear search in a similar fashion to how we defined the inject operator. Well, I'm not sure what the right way to say that is. Okay. We need some stuff here. Okay, what next? There we go. So yeah, this is kind of one of those those situations where you just start adding language extensions until it compiles. So again, the nice thing about the LSP is it pretty much does it for you. Yeah. That's exactly correct. This is just to prove that something is in the list. The final trick is to declare the F monad as a freer monad over the union of a set of effects. Okay. I don't know what RS stands for. what's up? I'm just gonna call you Wind. And bot from channel. Bye. Every time I get a message like that, it's like immediately I just assume it's a bot. That's why you could tell I was leery already. There's so many. Just like, if you want to be a bot, fine. Just don't bother me. I don't know what the point of the bot would be then. To steal information from you guys, maybe? I don't know. Scrape information about my channel so they can sell ads? I don't know what Twitch does. I assume they don't need to send bots out to do that, so. Anyway, so we're gonna need to create import freer, and we need to go build freer with the code from here. Bots. Doop. Do. Do. And the other thing we need to do is just drop this. Oh yeah, I guess we can do %s pure prime pure g format, and we're done, I think. Yeah, I've gotten a lot of those recently. That exact bot or something similar. At least they don't post links, so they're like automatically removed. So, well, they're gone now. It didn't look like a real person. Man, if it was a real person, I feel bad for them. Don't. What did I just do? Actually, it'd be funny to build a Twitch bot that checks to see if people are bots. Like, it Turing tests them, yeah. That'd be kind of funny. Yeah, but those bots don't, I mean, look at the name. They're not even trying to hide the fact that they're a bot. Have you ever seen a name like that on Twitch? I haven't, anyway. Okay. So we've defined this effect type. Okay, so the same data types we use to declare operations for freer monads, excuse me, serve as effects in this new setting. We can readily reuse fs and random gen from previous sections. So we should just go get their definitions, I suppose. So this looks to me like, which one? Final, I guess. This is... Wait, which style is that? That's not the right one. What is this? Did we write this one before? I don't even know. Yeah. Actually, I mean, it's easy to explain what a monad is, right? It's hard to gain intuition about how you use monads in reality. Because a monad is just a interface with two functions that obeys some laws, right? That's it. That's all a monad is. There's no more magic than that. I think that was my favorite section in the what was that book called? Haskell Programming from First Principles. It's an interface with two functions that obey some rules. It doesn't matter whether it's programming or not. That's all it is. If it's a data type that obeys those rules, it's a monad. I don't know if it's easier, because you need to understand category theory. And that's not particularly simple for, like, Joe Schmo either. Okay. Yeah, see, that's already more work. No, it's more than that. Because the arrows mean something very specific. Like, even if they just look like dots and arrows, that's not fair. And then there's, like, if you look at a particular category, right, it probably derives from some other category, and then it's also related to a bunch of other categories. And so, like, you can't just rip out that little picture and be like, yep, that's it. That's what I'm finding. It's another rabbit hole. Just like using monads in Haskell is a rabbit hole, right? But the monad itself is not, it's not magic. You can look, you can Google it. It's I think you have an idealized view of how people understand things. I don't know. That's probably not the right way to say that. How do I say that correctly? I don't know how to say that correctly. Someone like me can't read one page of anything and understand it. Because I need more detail than one page. I wrote a 300-page dissertation on a tiny subset of the world. tiny subset. And I still don't feel like I understand that entirely. So anyway. Member? Member's the thing we wrote before. I want to read SICP as well. It's free, right? And that uses like a scheme or something. Maybe I could use that to learn not common Lisp, Clojure. It could be interesting. So this already kind of looks familiar. This is going to be a generic smart constructor for our random gen, or I'm sorry, our FS effect. Yeah, finishing books is hard. It's like you start getting, you know, to the point where it's like getting harder and harder and harder, and then eventually you just get to the point where like I'm fed up, and I don't want to go any further. But luckily, I'm really stubborn. It's a blessing and a curse, really. Yeah, like at the end of this book, it almost feels like we've given up on trying to learn anything, and we're just going to show a bunch of source code and then like sort of just get it. So these constraints here, we sort of talked about this before, but this constraint is basically just saying this RS effect better be in the list of, wait, no. It's saying FS better be a member of the effects. That's what it's saying. So file path F RS either IO error string file path. One nice thing about doing this is it starts to look pretty similar, and I'm guessing it's basically the same function. Read file path pure. I'm guessing it's that. Yep. Pattern is always the same. Obtain the instruction from the data type of operations, inject it into union, and finally bind it to a simple return instruction. You can even write it as the following function. RSF send. Okay. You ever want to do SICP and have no prior experience with Lisp Clojure, I actually recommend you use Scheme. Neither Common Lisp or Clojure translate directly. Racket. Oh, interesting. Okay. I'll keep that in mind. I've never done a Lisp language. That's actually one of the things I'd really like to do. I kind of really want to do the Haskell. What is it called? Pretty sure it's her. Yeah, Hackett. It's basically Haskell embedded into Racket. More or less. But apparently there's some nice stuff with I don't know, something that makes it nice. Macros, is that what they're called? Yeah. So you basically just are, you kind of just know this language, and if you know Haskell anyway, and apparently it's pretty easy to just use this. Anyway, what's up, Pick? What's Tapple? I don't know what Tapple is. It's probably FA, I would guess. No, it's just RSA. Types and Programming Languages. That's a mighty fine book. This is supposed to be X. Okay. Yeah, like, again, sometimes you just kind of know that your errors are obvious, so that's kind of nice, I suppose. And I guess that means we get to write send write file path. So we haven't talked about this yet, Illusion, but the best part about Haskell is you can do stuff like this. Although maybe it won't compile. It doesn't compile, sorry. I'm not entirely sure why. Oh, right, because it takes two things. I need Blackbird. You can write weird stuff like this. So this basically means, like, it's called point-free notation, and you can basically remove you can remove arguments by applying them. So this basically will apply to both path and contents, and we don't need to write them. And then this shape here is called, I think this is the Blackbird, right? Is this what that one's called? Pretty sure. Anyway, it's like a shape that just says if you have a function that takes two arguments, you can pass a function that takes the result of this with this Blackbird. So it's kind of cool. And you can do the same thing here, which is nice. So, like, it's super easy to write this because you can just write send dot, once you see the pattern once, it's like cake. And here we don't even need this Blackbird because read file only takes one, so it's actually just send read file. More visual way. I'd be willing to see that. That'd be interesting. I've never seen it written in a different way. Oh yeah, I've seen that before. Yeah. Kind of looks like Cheshire Cat or something. Cheshire Cat? Probably that one. Yeah, Blackbird's cool. And so is point-free notation, because it's like really nice. It can save you a lot of typing. As long as you recognize it. The problem is, like, when you write it, you tend to write the full definition and then start pulling stuff away as you realize. So, unfortunately, that's kind of how I end up doing this. But anyway, we can also write this random one. So member random gen rs int f rs int random send random. That should compile, I think. Oh no, random takes two things, so we need Blackbird. It is, yeah. And when I started doing this, I felt exactly the same way. Like I watched some people do it on Twitch, and I was like, "There's no way I'm ever gonna figure this out." And I did. So, you can. It's just it takes time. It takes time. And you have to be willing to commit to it. Can recommend starting a stream. I'll watch it. It's a good way to be consistent about like learning. That's the only reason I do it, is to stay consistent. And also it's fun to interact with you folks.